Okay, let's unpack a concept that sounds really simple on the surface, but is actually pretty fascinating from an engineering standpoint.
Mm-hmm.
Imagine controlling a physical switch, like a door lock or a traffic light,
Yeah.
from miles and miles away, just
Mm-hmm.
using light.
Right.
So today we're doing a deep dive on the tech that makes that possible, specifically looking at the Thor broadcast F-2CC-B-TxRx2 bidirectional contact closure kit.
And our mission for you really is to get past the product name and understand what a contact closure actually is,
Yes.
and then how this fiber optic system lets you send these simple on-off signals reliably over, just huge distances.
And the mechanism itself is, beautifully simple. It's basically a remote-controlled relay.
That's a great way to put it.
You close two pins on the transmitter side, the TX side,
And instantly, the same two pins close on the receiver, or RX side.
which lets current flow and turns your device on or off. Simple as that.
But there's a key term in the docs here that's critical: dry contact closure.
Okay, what does dry mean in this context?
It just means the switch itself doesn't provide any power, it's simply closing a circuit. Your equipment has to provide the voltage.
Which makes it universally compatible with almost anything.
Exactly. And it's not just a dumb switch either, it can also handle 5-volt TTL pulses.
So it's ready for modern digital control systems, not just simple on-off.
Right, it can talk to other electronics.
Let's talk about the range, because that's where this really starts to get impressive.
This is the mind-blowing part.
The base unit works for 20 kilometers, that's over 12 miles, on single-mode fiber.
And even with standard multi-mode fiber, you're still getting 3,000 feet. That's a huge reach for a simple command.
So why fiber? Why not just a very, very long and well-shielded copper cable?
Well, you could try, but you'd run into a world of problems. Signal decay, for one. But the real enemy is noise.
You mean electrical interference?
Precisely. The whole advantage of fiber is that it eliminates the three big headaches of long-distance wiring. No EMI, so no electromagnetic interference. No RFI or radio frequency interference. And crucially, no ground loops.
Ah, ground loops.
Yeah.
The bane of anyone working with audio or sensitive electronics over a large area.
It's that constant, awful hum you get when grounds are at different potentials. With fiber, that problem just disappears. You get a perfectly clean signal every single time.
It's like sending a pulse of light through silent glass instead of shouting across a noisy factory.
That's a perfect analogy.
So the signal's clean, it's reliable. How flexible is this setup? Are we just talking one transmitter to one receiver?
No, not at all. You can do a standard point-to-point connection, or you can actually daisy chain them to link up multiple points.
And it seems pretty user-friendly. The documentation keeps saying plug and play.
It is. It uses standard STPC connectors. You plug it in, and the little LED lights tell you everything's working. No fine-tuning needed.
So given that reliability, where are engineers actually using this? What are the real-world applications?
Think big. Think distributed. Access control systems for a huge industrial park, or maybe a university campus.
Right, where running copper would be a nightmare.
Or municipal infrastructure. Traffic signal control. You're not going to run expensive heavy-gauge copper under a city street for miles.
Right.
You run a tiny fiber optic cable.
Building automation makes sense, too, for environmental controls. And I see fire and alarm systems listed here.
Yes, that's a critical one. Triggering an alarm event across a massive facility instantly and reliably, this becomes the silent backbone for all those systems.
So to sort of wrap this all up for you,
Yeah.
what we're looking at is a super reliable, adjustment-free way to send two channels of simple switch data
That dry contact closure.
and just zap it across up to 20 kilometers.
And it's totally immune to all the electrical noise that would just kill a traditional wired system.
Yeah.
It turns a pulse of light into a remote trigger.
Which really leaves you with a pretty big question to think about, doesn't it? When distance and electrical interference are no longer the limiting factors, how does that change the scale of the automated systems we can design? What kind of massive infrastructure sprawling port authorities, smart city grids, suddenly becomes easy to control from one single point? Something to chew on for your next big project.